Hello, everyone. Welcome to the webinar, Why GNSS is an Essential Quick Clearance Crash Investigation Tool. I'm Christine Grail from Leica Geosystems, and I will be the moderator for today's session. Our instructor today is Andrew Klane. Andy is a retired Massachusetts State Police Lieutenant who has more than 25 years of experience reconstructing serious injury and fatal motor vehicle crashes. He is accredited by the Accreditation Commission for Traffic Accident Reconstruction, or ACTAR, and has testified numerous times as an expert witness in both district and superior courts throughout the Commonwealth of Massachusetts. An expert in the forensic mapping of crashing crime scenes, Andy has dedicated a significant portion of his professional career to bringing technology into the reconstruction of motor vehicle collisions and crime scene mapping. This technology includes total stations, laser scanning, and aerial photogrammetry using unmanned aircraft systems, UAS, also called UAVs or drones, as well as GNSS. During his time with the Massachusetts State Police, he was commander of the Collision Analysis and Reconstruction Section, or CARS, and implemented GNSS mapping systems as a primary crash investigation technology. Today, as CEO and principal of Forensic Mapping Solutions, Andy provides sales, training, and implementation services for GNSS, as well as other technologies that maximize forensic mapping efficiency. Also on the line with us today is Ryan Roselli of Leica Geosystems, a Hexagon company. Ryan has an impressive resume in his own right. As a CSI and forensic specialist for nearly 16 years, 9 of those as a supervisor. Ryan has specialties in CSI, crime scene reconstruction, bloodstain pattern analysis, shooting and incident reconstruction, photography, and forensic mapping. He's a recognized expert in forensic laser scanning, and recently he's been spending a lot of time evaluating the full potential of GNSS with the newest technology, the Leica GS18I rover with visual positioning. Ryan will be answering your questions behind the scenes as well as in the live Q&A following Andy's presentation. Now, we do welcome your questions during the presentation today. You can enter your questions in the questions box, which you should see on your screen. If we are unable to answer all the questions in our live session, someone will reach out to you after the webinar by email. And before we get started today, we have a few quick polls that we want to share with you just to get a better idea of who's in the audience today. Our first poll is about your primary area of focus. And I suspect that we have a lot of people in the audience with us today who are involved in crash investigation, but maybe you are involved in crime scene, maybe you're doing some other area of work. Certainly GNSS is not limited to crash scene investigation. So we just wanted to get a handle on what it is that you primarily focus on. It looks like a lot certainly are crash, but we do have some other things in the audience today. So I'm going to close this out and share the results. All right, we have just a couple more polls here. I'm interested in what is your primary scene documentation tool? Are you still using manual measurements primarily, or using total stations? Maybe you're already using GNSS and you're just trying to get a feel for what the latest and greatest is. Or maybe you're already using laser scanners. I know we probably have a lot using drones. I'll give you a second to answer this. Looks like we have a lot of people on the line with us today who are using laser scanners, so that's fantastic. I'm going to go ahead and close out this poll and share the results. All right, and one more poll before we dive into our content today. And this is just with regard to if you are using a drone UAS or a laser scanner, how are you capturing your ground control points? No wrong answers here. We're just curious to see what is actually happening with those of you who are in the audience. Looks like a lot of you are using GNSS already, so that's fantastic. Okay, I'm going to close this out and share the results. And then we will get into the main topic of our presentation today. So obviously, we are talking about GNSS. And I can't think of anyone who's better able to address this topic than Andy Klane. Andy, I think the first thing we need to do is define What we're talking about with GNSS, which refers in a broad sense to the Global Navigational Satellite System. A lot of law enforcement professionals are probably more familiar with the term GPS, which refers specifically to the US satellite system rather than global. But I think we probably need to differentiate between what's commonly used on the consumer level and what we're talking about with professional grade GNSS.
Sure. Good afternoon, everybody, and thanks for attending. As Christy said, we're so familiar or used to hearing the term GPS, and the types of environments that we use that in are on our cell phones for potentially geotagging images, or for your Google Maps or navigation apps on your phone. But the accuracy of those just GPS units are about 3 to 5 meters. So you could be 10 to 15 feet off in your positioning. With the GNSS, what it's doing is it's also bringing in navigational satellite systems that have a lot higher accuracy and reliability. And by pulling all those together from Russian satellites and Chinese satellites and blending that in the GNSS, we're going to get a much better positioning just from the GPS alone. And then what happens with this technology is once we get that positioning, the GPS goes over a ground network called a CORS network, or continuously operating reference stations. They're known positions on monuments that have been set by surveyors, and then they are acquired through a provider. And then basically you log on to that provider's services, it goes over the internet, and then it corrects those positions from the known positions down to hundredths of a foot. So that's ultimately why we can use this technology to map a crash or crime scene, or in the survey world, this is used all the time to do survey work because it's very precise.
Okay, excellent, great to know. So even though this technology has been used in land surveying for quite some time, it's still relatively new in the world of public safety. I'm going to show a couple of photos here. Now, I don't think that your crash investigation days go back quite far enough to that black and white photo on the left, but I'm sure you had some experience with manual measurement techniques when you first got started. So can you tell us a little bit about your technology journey in the early days?
Yeah, so actually when I did start as a police officer in 1988, as well as crash reconstruction in 91, we did use coordinate measurements and tape measures to document our scenes. That's really all there was, and that's how it was done. Obviously not as accurate as what we're doing today in any shape or form. And at that point, in the late 90s, we ended up going to total stations, which now are going to give us a lot better precision and accuracy than using a tape measure. And obviously that was equipment that, again, was used by surveyors, but became more cost effective to purchase. But when I first started learn how to use this, we were taught by surveyors because there was no such thing kind of forensic mapping and the development of using this equipment for a crash and crime scene.
Yeah, and I think total stations are still very commonly used for crash scene investigation. What do you think that is?
Well, it's still commonly used because, first of all, the people are comfortable with it. It does a great job. They're comfortable using it. The price point is good. But on the opposite side, we end up with a situation where we're using and measuring it in a local coordinate system. We're taking all our measurements from an arbitrary position, which is fine. But with today's technology, working in an actual coordinate system can give us some benefits. And also, you know, the total station, you need 2 people to operate it. There's the issue of sighting the total station, communicating the coding that we're going to do, and it's still a good tool, but there are more efficient ways to do it.
Sure. And then obviously, you know, about 10 years ago, you actually, within the Massachusetts State Police, you moved into using GNSS. So help us understand what led to that change in your approach, where you went from using primarily total stations to now using primarily GNSS.
Yeah, so it was about 10 years ago. It might even have been maybe 12 to 15 years ago. But at that point, the state police was just using a total station, and not everybody had a total station available at that point. And we were looking for another piece of technology, that's something that would be faster and just as accurate. And I was actually working a construction detail, overtime detail. And when I was at the detail, there were surveyors that were there using this GNSS technology. And I was aware that prior to what you see here as a standalone, they had systems that have a base station, and then they'd have a rover that connected to the base station. Well, now the rover connects to the internet and does it that way with the GPS. So I kind of got curious about it, worked with them a bit, did some research, and then we ended up going to Mass DOT, and we were involved in some traffic incident management quick clearance initiatives. And I was able to have them assist us in purchasing 10 of, at the time, Leica GS14 setups, which you see in the photo on the left. And it was a game changer for us because you only need one person to operate it. It works in all different environmental conditions, and it just gave us a lot of benefit to clearing a scene faster and getting the measuring done sooner, because we didn't have to wait for a second trooper to get there. A lot of the areas we covered were rural, and it could be an hour or more before we could get a second trooper there to assist with mapping.
Yeah, absolutely. We have an article on our public safety website, which is actually that screen capture on the right there. So I will make sure to include that link for anyone who wants to do a little more of a deep dive. But briefly, because I know that you kind of made a leap there when you went from total stations to using GNSS. And so I wonder what some of the first things were that you noticed when you took those out into the field. I mean, 10 GNSS units. That's a pretty big investment for an agency. And so what were some of the key benefits that you noticed right away?
So the first thing was, as I said, the fact that we can operate it with one person. So that would allow us to get underway faster, and it would allow us to be more efficient and faster just because of the time it takes to take a measurement with GNSS. With a total station, you have two people, you have to sight the instrument on the prism pole, you had to enter in the code, then you had to wait for the measurement, and then that person would have to walk to the next location, and so on, which I'm sure most of us on this webinar are familiar with. With the GNSS, you put the tip of the GPS pole on your piece of evidence, and at this point, plumb it up level and enter your code and hit the button. So it's a lot faster, and it's also just taking out that sighting and all of that, acquiring a position real time there. And that
Andy,
in turn lets you process the scene faster.
Hey, Andy, this is Ryan, and I just wanted to interject for a moment, because even if somebody is using a robotic total station where it can be single person operation, there is still merit because you're carrying that single piece of equipment in the GNSS and the data collector at with a single piece of equipment versus having the prism out and roving and the total station instrument there. So for those, because I do see some folks in the room that are very sophisticated total station users, can you speak just for a moment, even the merit of GNSS against a total station per se, for those using robotic?
Right, so that's a great point, Ryan, is with a robotic total station, for those that aren't familiar, basically you still have to set up the instrument, and then there's still a prism pole and there's still a data collector, but you can walk around and the total station will follow you to the prism, and it works fairly well. There are issues with it disconnecting or losing that lock if something gets in between it, but you're still having to wait for that to catch up and take the measurements. And with GNSS, we don't have to worry about that. The other issue is the fact that you still have to set up a total station. You still have to occupy that point. You need to shoot a backside of reference direction. The setup is the same. With the GNSS, literally you open this little red case, you put the antenna on the pole and turn on the data collector, and within 60 seconds we're mapping. There's not as much equipment to carry, and it's just a lot easier to do. And then the last piece I think will tie into whether it's robotic or not is GNSS works in a coordinate system. So we're familiar with latitude and longitude. There's other coordinate systems that are called state plane coordinates. It's more of a coordinate system that a GIS or a surveyor would use. But the GNSS, by having that known position rather than being arbitrary, it allows us to integrate other technology with a total station, GNSS, laser scanning, drones, all of that.
Okay, excellent. And I think you have an example that you want to share with the audience of, and this was again from several years ago, using the earlier the earlier GNSS, the GS14s, I believe. And you are involved in investigating an actual crash. So tell us a little bit about what we're looking at on the screen right now.
So what you're going to see is a surveillance video from an auto dealership in Massachusetts on Cape Cod. And what you see in the background is Route 28. There's 2 lanes in each direction with a positive barrier down the median. If vehicles you're going to see traveling from right to left. To the left is a rotary where traffic coming over the Bourne Bridge from the mainland, so to say, is. So the traffic here backs up. So what I want you to do is just watch the flow of traffic from your right to left, and then keep your eye out for a white box truck that's going to enter the screen. And as you can see, the traffic was slowing, and our driver of the box truck was not. And he rear-ended 2 vehicles and ended up killing the passenger in the first vehicle he struck. So this scene we responded to and went and mapped it using GNSS. So in this screen, what you're seeing is the GNSS points for all of us here that have used the total station or GNSS. This is your typical set of points that were shot by placing the tip of the GPS pole on your evidence, whether it's skid marks, gouge marks, pavement markings, roadway features, edges of pavement. We would literally need to go and put the GNSS unit in that location, take a measurement, and it would log this data. So what you see is an actual point, a descripting code, an elevation, and a point number. It's nice to note here too, though, when you're using GNSS, you're actually getting an actual corrected elevation rather than just the height above the instrument with a total station. So you're really getting the real world mean sea level elevation when we do this. So that lets us really be in a really nice 3D environment.
Okay, excellent. Now, just within the last few years, we've seen significant advances in GNSS rover capabilities, so that now even basic GNSS rovers can provide high performance data collection on a wide range of scenes. We removed a lot of the previous limitations, right? What should investigators consider when they're looking at a GNSS rover?
So as you just said, the technology in the equipment itself, whether it's a entry-level basic piece of equipment or a piece of equipment with a lot of bells and whistles, the GNSS portion is so far advanced than 10 years ago. So with that in mind, because we're acquiring a lot more satellites from different systems, the positioning gets better. And where that comes into play is that to use GNSS, you need to have access to the satellites. You need clear view to the satellite. So if we have more satellite systems, the chances of us not getting that clear view to lock in on just one system, now we can use it in areas where before you might have heard, well, there's tree cover, I'm too close to a building, a lot of different issues that was true. But now with technology, we're getting away from that being a problem. The other issue is we need to have access to the internet. So if you're in an area where your cell phone coverage is spotty, then you're not going to be able to get the correction to operate this equipment. But pretty much, those are the limitations, if you want to call that, in this equipment. But there's obviously a lot of benefits as well.
Yeah, and certainly with the newer models, a lot of those limitations have been overcome. So even with the most basic systems, like what we're looking at on the screen here, I think you've overcome a lot of that. And then there's even newer technologies, right?
Yes, and that's a good point. I think we're going to show you a little of that. But the entry level equipment of today is more than adequate to do what 10 years ago you couldn't do.
And then we have new capabilities like tilting.
Yeah, so now let's address one of the issues that was a problem or something that people had issues with GPS with. Now is basically for two things. It's called tilt compensation. This is a great technology for a couple of reasons. One, prior to tilt compensation, you'd have to plumb and level that prism pole, and you'd have to hold it as best as you could, just like a total station. If you weren't setting, a bipod on each point, you'd have to level that out. And let's face it, if it's not totally level, then you're not going to get an accurate position. And actually, the GPS on its own would have to take what they call observations. It would need 3 to 5 observations or measurements that it took to average them together to kind of deal with the fact that the pole's moving around. With tilt compensation, there's an IMU or an inertial measuring unit inside this antenna that it can calculate the exact position of the tip of the pole based, even if there's a lean or an angle to that. So why that's so huge is, number one, you're going to get an accurate shot every time. And number two, it only takes 1 second to acquire. It needs one observation, not more, because of the way that the tilt compensation works. So that in itself will allow you to move along very quickly. And honestly, once the code's in, if you're at an edge of pavement or a fog line, you can literally just almost not stop, put the pole down, push the button, and move on. The other thing that's nice about it is if you need to get under a vehicle, if you need to get under an area that you can't keep the pole straight, you can lean this thing, 20 degrees, and it's still going to get the shot. So you can, gather evidence that's maybe underneath something or not as accessible. And that's what the tilt compensation kind of brings to the table.
And then, of course, the most recent innovation is the ability to use visual positioning with GNSS. So tell us a little bit about those.
Yeah, so this is actually, this is pretty cool. This is relatively like a month old being rolled out. We just did training with it. I've used this a bunch lately, and this is a whole new thing, because think about if you can't get your satellite lock, in other words, you're in an area that it's a little denied, then we would not be able to get those measurements. So what this does is, let's say I'm going to need to get close to a building, or I need to get out from under some tree cover, or whatever the obstruction is, I can move back a bit with the GPS until I get my fix, because I still need a locked position. But then I measure from images. I take and hit a button, it's called visual positioning, and I'm going to kind of walk with that pole, almost like I'm scanning it. I'm going to walk in almost like a radius, because we don't want all the photos to be in a straight line. And it takes the photos by itself. It can take up to a minute of photos that are spaced out. After I finish that, I say I'm done. It literally processes on the data collector or the tablet, and now I can go in and select points that were not accessible before and get the same rock solid measurements because it's using the images and photogrammetry to grab those positions based off of the position of the GPS unit. So from what I've used with this, it's pretty much, you get 20, 30 feet away, you can be that far away and take the photographs. So it's really eliminating a lot of the dead spots, if you want to say that. Plus, you can also use it to document a vehicle. Even if you have good GPS coverage, you can go and basically do photographs around a vehicle and take your measurements off the vehicle and create a point cloud from it in the software. So it's really, really a great improvement or development with this type of equipment.
So you're talking about GNSS, which was already a fast way to get started. You get to the scene, and within 60 seconds with GNSS, you can be collecting data. And now it's even faster because you have the imaging capability, right?
Yes, all these improvements really take, and that's no stretch at all to say 60 seconds. It might even be faster when you're good with it. And what you're waiting for is just for it to lock in. But to set this up, you're off mapping. And the other thing that's nice is anybody that's used Total Station, and now you got to come back. You need to take more measurements. We would have to find the position or the occupy location on our backside, or do what's called a resection, set up somewhere else and shoot 2 common points. The GPS is referenced to the coordinate system. So I could come back a day, a year, a month, whatever it is later, and start mapping again. And if you want to take it to the next level, let's say you have a large scene and you have more than one GPS. I could have one officer start at that end, another one start at the opposite end, and all I'm going to do is take that data and merge it together back at the office, because it's independent, and it allows you to cover a large area, without being pinned down, so to say.
So it's probably eliminated a lot of those situations where in the past you couldn't use GNSS, right? Because you didn't have access to the satellites or whatever that issue was. It's probably eliminated a lot of those.
Yes, it has, and I, in my estimation, I would say that this technology with all these advancements, is probably good to go 95% of the time in most situations.
Okay, now you are obviously in a position where you are now selling the technology in addition to training and consulting, but you've been involved in crash investigation long enough that you want to have a level of confidence in what it is that you are recommending to your clients. You want to make sure that it works. You want to really push it to the limit. And I think that's what you did recently in a mock scene that you want to share with us here. So I'm going to advance and tell us a little bit about what was happening here.
All right, so we were just in Sandy Springs, Georgia, doing a training with Pix 4D and other types of equipment, and I had just gotten the GS18I. So I brought that along, and we used it to process the mock scene in conjunction with some other technologies. We used the GNSS, we used the drone, we used the laser scanner, and we put to the test the features of the tilt compensator and the features of the visual positioning, as well as just the GPS technology, GNSS technology on its own. And these were some of the students and one of the instructors in the class that they had never seen this before, and it's so simple to use. Once we started showing how it operates, and they've seen GNSS, but not this, and these people were off mapping very seamlessly in a short period of time. And also the visual positioning was, it was insane. It worked perfectly. So, my experience with this so far is that it's exactly what everybody said it was. And as you said, I don't like to recommend or get into something that's not going to be right for our customers, because I've been on the receiving end of that before. And now with my business, I want to make sure that that's how we're doing it.
Absolutely. Well, and we have an image here showing how you were using the laser scanner as well. And I think you have some examples of what this looks like when you start pulling it into mapping software, because that's ultimately the goal, right? I mean, you're out there collecting the data so that you can create a map that shows exactly what happened.
Right, and that's a great point, because all of this technology is wonderful, but if you can't do anything with what you collected or measured and get that to a point that you can use it for your crash reconstruction diagrams for court, crime scene diagrams, measuring off the scene, then it's for naught, so to say. So what I have coming up in the next slide is using Map 360. What you see here is that all I did is import the GNSS positions from the GNSS unit. There was nothing else used for this slide. And then I positioned vehicles from the library in their final rest positions, put down a body and some evidence markers. Now, obviously, this is a very simple scene. I put the parking stripes in just to give some reference to where we're at. But this is really using the GNSS points to draw the tire marks and do that. So just with that technology, I can start to draw diagrams. And now this screen is just a close-up of that with the evidence points turned off. So the nice thing with map is that you can now, after you've done your positioning and drawing on the screen, you can shut the layers off that have the points, the elevations, to really make it look cleaned up. And like I said, this is simple, but I think it kind of gives you an idea of what we're trying to accomplish here. And then this slide, same software. What we're looking at here is the point cloud from the laser scanner with the GNSS measurements on the same screen. But what's interesting about this, what I had said earlier, is because it's in state plane coordinate, and I basically put what's called ground control into my scan, which is very simple. When I bring them into map, they both line up perfectly because they're both in the same coordinate system. Now, if these were total station points, I would need to align them manually because they don't have that positioning. They're all great measurements relative to themselves, but I would have to position this. And the nice thing with this is I also get what's called you get a quality report out of the scanner showing me what my accuracy is of my targeting. So, and then I get the raw data from the GNSS. So this is a real nice way to pull together different technologies, and there's not a million steps to this too. A lot of people, oh, you can do this, but you need 3 pieces of software and all kinds of training in each one to make something like this go. Well, this is really just import both of the scan and the points, and it comes together by itself.
And then I think we have, you said you used a drone for the Sandy Springs situation as well, right?
Yeah, so it goes back to the same. If you look in this, you can see the targeting on the ground. Those are ground control points, that same targets that I marked in the scan, but these are the ground control points that we mark in the drone flight. And then we use the way that this gets pulled together. A common thread here is the GNSS. The GNSS gives us the positioning of those targets so it can pull it all together. So now all I did is take the ortho image or the orthomosaic image that was created by the drone and insert that, bring that into my Map 360. And again, because it's all in state plane coordinate, they all line up. So I can have all of these different types of media evidence, different types of environments, all laid into one drawing in one place. And that's the nice thing with map, because it does work in a coordinate system. A lot of softwares don't. This one works very well for doing what we're doing here.
So we're really seeing some advances in software as well as hardware, which all work together to make GNSS that much more valuable. I know we spent some time talking about the latest and greatest GNSS, the GS18I, but you get a lot of these same advantages even if you're just using the basic of the most modern technology. You know, going back to that crash scene that you guys mapped using the GS14, you were able to get a lot of benefits from overlaying those GNSS points with the drone imagery, right? With those orthos.
And that's a great point. So everything I just demoed or talked about from Sandy Springs that you saw was all basic GNSS technology. We did not, even though we have the tilt compensator, nothing really there was from the bells and whistles, so to say. Now, if you have those bells and whistles, there's a lot of advantages to them. But I think what you're saying, which is true, is you don't need to have all those features to use this. And there is the example. That's a lined up image with an ortho photo back from 2017 with a GS14, and it lines up perfectly. And that's when I started, and Mass State Police started doing this. And as a side note, those GS14s are still in service today, and they fight over who's going to get to keep them in their cruiser because they do a great job. And it's real simple for the reconstructionist to get out and start collecting data.
Sure. And I have to wonder, we're talking about, in the last few images that we showed, talking about bringing together different data sets. I know a number of people said that they're already using laser scanners. Maybe they're already using drones. Is it really necessary then to have a GNSS system if you already have these systems, or if you're just looking for this one all-purpose tool? Wouldn't they be better off going with a laser scanner or a drone, or is GNSS really, in your view, necessary? I mean, you've done this for years, Andy.
Yeah, so using multiple sensors like a laser scanner or drones, what ties it together with what we're showing here is the GNSS. If I'm working with aerial photogrammetry with Pix4D, the only way that I'm getting really, really good accuracy is through having ground control measured with GNSS. You saw some people in the poll say scale constraints. It didn't look like too many people were using a total station. They'll all work, but the best way to be able to do what we're doing is with that. Now, step back. What if we're in a situation that, no, I can't afford the other equipment. There's time, like you can't fly a drone at night. I mean, it can be done, but it's very difficult, and there hasn't been a lot of success with it. You need a nighttime waiver to do it. Bad weather, if it's raining or snowing or we all know we don't go out to crashes on a beautiful sunny day all the time. So there's limitations to a drone. There's limitations to a scanner. So what I look at is you have a toolbox. If you're lucky, you have all the tools. If you don't, well, what tool will work most of the time and give you accurate data? The GNSS, you can pour buckets of water on it. It's not going to matter. It's waterproof. You can use it in the bad weather. You're not going to get reflectivity back from a scanner that's bouncing off of snow or rain. And you can get these accurate measurements deployed with one person. Doesn't matter where it is other than the little constraints we talked about. So if I was looking at, if I could have one thing and that's all I could have, I personally, that one tool would be the GNSS because I can do the most with that. Now, having the others, it's also nice that you're not buying something or getting something that now you can't use with other equipment or other software. And that was a big thing when I was the unit commander in Massachusetts was, are we buying something that in 2 years is not going to be any good because of the technology, or it doesn't, if I want to use this with that software, well, now I need this software and a license to this and that. And I think you see what I'm saying. This stuff now under the umbrella of Leica and even some other stuff, we can pull this together. We can, and that's a key thing, that you're not buying something that you can't use with the rest of it. So that's kind of my 10-cent version on that, but it's all great technology. But if you had to make a selection of one, that's where I would start.
Okay, excellent. I know we had a number of questions come through as we've been speaking. I do want to put this slide up quickly for anyone who wants to take down contact information for either Andy or Ryan, but I do want to get to some of those questions. Ryan, you've been watching the questions as they've come in. Which one do we need to tackle first?
Well, I'll put this to Andy so he can kind of dive into this one, and then I'll get you the next one lined up. But someone had asked, typically how many crashes occur in the state of Mass a day and how many require investigation? I think what they were getting at is, we have this ability with GNSS to quickly tackle crash scenes with a greater speed. I mean, how much is this efficiency needed at the statewide level? I mean, the value is it, you know, is there a volume of crashes that require investigation where deploying this type of equipment brings value to the investigation?
Yeah, so in Massachusetts, we reconstructed between 500 and 600 crashes a year. And those would be fatal and serious injury crashes, not your everyday, you know, minor injury fender bender. So if cars or the crash reconstruction group was called out, that would be 500 to 600 crashes. And so technology like this was used all the time. Now, even if you were in a situation where you didn't have that volume, if you're trying to do a professional solid crash reconstruction, you need to have the technology to be able to use it, to be able to go into court and do the work that needs to be done for prosecutions, or to exonerate someone that was involved in a crash that may have not been their fault. So I understand that, but, and you know, there's always, you know, you make a big outlay of money, you know, the more you use it, the better, I guess you would say, I think is what you were asking, Ryan. But even in situations like this is, you know, you're going into court now and your defense experts, people that are not in public safety like myself now, are going in with this technology. So it's one of these things that we get calls all the time to help departments bring themselves up to current technology. And a lot of it wasn't because they didn't want it, it's because there was no money for it. And now things are starting to loosen up. And that's kind of what we try to do, is help them find the best solution to getting up to speed.
Absolutely. Thank you, Andy. You know, another of the questions, so a lot of the questions that were asked, just to kind of clarify, because Krista, you're right, there were a lot of questions, very, you know, specific, you know, do you need is the data collector connected to the pole? You know, how can you export, things like that? And I answered those in line. So, I mean, you know, just roughing in some of the questions that we faced. The data collector is separate from the pole. The data collector is separate from the GNSS unit. These are all different components that come together to basically be assembled in that GNSS assembly. As far as export, number one of the things that was asked was, can you export in formats that can be imported by really any software? And the answer there is very simply yes. You know, the Captivate data collector software allows you to export in a wide range of formats. The DBX is typically the export package we use for Leica softwares. However, you can do comma separated values, text files, TXTs, you know, DXF, ASCII. You know, there's a wide range of ways to get data from the collector to whatever software you might be using. So, you know, very versatile in that form. So you can collect and then go into really any software that's out there and available. Somebody had asked about using a different brand of data collector with the Leica GNSS. There's some crossover that is possible. However, the GNSS systems that use the tilt, you know, the GS18I that uses the imaging, that has the imaging capability, any of those advanced features are built into the Captivate program of the data collector. So if you're trying to integrate a different brand of collector with our GNSS, you're typically going to reduce down to the ability to measure point at a time. You're going to lose the tilt, you're going to lose the imaging. So whereas I say, yes, it is potentially possible, depending on the make and model of the collector you're trying to merge with the Leica hardware, it may limit the functionality of the system that you're trying to assemble. So it would just be something that you want to investigate as to whether or not, you know, saving a few dollars by not investing in a Leica data collector would be the way to go. So we have a data collector, the CS20, that has a disto, a laser rangefinder built into it. With that disto, if you have a point that's under an overpass or something that cannot be reached where you have RTK correction, you can use that disto to observe a point, measure a distance, observe a second point, and measure a distance, and you can plot that point under an overpass or, you know, within an area that doesn't have RTK correction using the disto. So to say that there's great value by working with the Leica data collector, it's beyond just leveraging the imaging or leveraging the tilt. It's also being able to eliminate a long feared weakness in GNSS, not having RTK correction to observe a point. So with that disto feature, you can do distance, point, absolutely builds value into the solution. So, that's really what this is about is, and truthfully, the CS20 or the CS35 plus the instrument, it's a package that brings a series of features together that work together. And again, it's not to talk specifically about these instruments because we're talking just about the technology today, but when you're looking at it, you want to look not only at the fact that it's collecting a coordinate that's known against the world, but what does the whole configuration of equipment bring together? And I think different pieces of equipment do different things, and it does have great value. So Andy, I'll let you add to that because about 7 questions came in while I was talking, so I'll take a peek at these.
Yeah, no, I think that that you hit the nail on the head, and the only other part that I could add to that is it's like different manufacturers do things different. There is a benefit to keeping everything the same brand, and I've seen this where you can cross brands, and a lot of time it isn't because you don't want the other. It might be a financial thing, but as you said, these are they're meant to work their best with the same data collector. You could end up using something else and not be able to get all the satellites. You may not even be able to. So it's designed to work together. I would just be, ask the questions. If you're looking to get something like this, whoever you talk to, ask them these questions and see if what you have may work or may not. But this is all really designed to, integrate with it, with like hardware, especially these newer ones.
We did get some questions specifically about the 18i, and I want to make sure that we can address a little bit of those. Now, we are planning to do a more in-depth webinar on that technology specifically and all the capabilities coming up probably toward the end of January. But I do want to address these questions if we can. And one of them is, what do I get specifically from the imaging function? So, and if you could talk through that a little bit, because I know you had it out, you were testing it, you were trying to see what is it you get when you turn on the imaging.
All right, so the imaging function allows you to take measurements of objects in the image set that you could not get with the GNSS pole, because if you went to that location, you would not have your RTK lock and the measurements wouldn't be accurate. So the theory is here is we're going to take these images from a location where I have the GNSS correction, which could be anywhere between 0 and 30 plus or minus feet away from the object, take the photographs, and you don't have to snap them like a camera. You push the button, it takes a group of photos, and then literally I go on the screen and pick the point that I want, and it will get its position. So basically you're surveying in the photograph. If it was a crush vehicle, I could get all my crush measurements just by tapping on the vehicle and exporting those measurements. So think of it, it's no different than if you push the button and get it with the GPS. I'm just getting those measurements from the photo. And it's also good to note here that this can be done on the data collector in the field, or this can be done back at the office on desktop software. So as long as you get the image set, you can go map on your computer, pulling points all day long. And what's nice about it is, say you missed something, say you forgot to get something by putting the pole on it. If I have my data set, I can go back and measure anything in those photographs. So that's the benefit of it. And as a side note, I said earlier, you can also get a fairly decent point cloud out of it too. Not like a laser scanner, not like a drone, but you get a basic point cloud out of the desktop software. So the big thing is to get the stuff you can see, not actually put your hand on, is kind of the way I would say it, which is a big issue with GNSS. It was a big issue. So now we're eliminating that by 2 things. We have better equipment, more satellites, better acquisition, and then if that still doesn't work, we have the ability to use the images.
Great point.
Absolutely, and so I mean, my enthusiasm for the GS18 is fairly unbridled at the moment. One of my flaws, I think, is that I get very excited with this equipment as it's coming out. It's one of the reasons why after 16 years in the industry, working for Leica has been some of the best years of my life, because every time we get something new, I get to go out and experiment with it and find out the ways that it fits into our world. But the GS18i has just been stunning as far as the things that I've been able to go do with it. And it's, I've gone out and done some test sites, and I believe that Christy is going to post some images in a follow-up to this, and I'm excited to see how those look. And again, it's just been me experimenting, and I plan to do more. But the ability to take those image sets and convert them to a point cloud, to measure within them, it has expanded the world of ability with GNSS beyond anything we've ever seen. And the truth is that the tagline is measure what you can see. And again, I'll spoil it a little bit. She's going to post some images I took out at a baseball field, and I went out there because it's a place that I know. And so I measured all of the fence joints where all the fence posts crossed over on the backstop of the baseball diamond. Could not have reached them. It goes up like 15 feet on this fence, and to be able to measure that, as Andy was saying, like, look, with old GNSS, you couldn't go near a building. The building would interfere with the signal. Now to be able to back up 20 feet and to walk around that building and to be able to pick the edges and corners of that building to measure them, really just amazing. And then to be able to take the point clouds, and again, they're not laser scanner point clouds, without a doubt. You have to get the photos to build the point cloud, and getting full coverage to build an intact object that you want to build a point cloud of with the GS18i, that's not what it's built for. But you can take those and interface them with point clouds from laser scanners, and you can take the points that you're measuring with any GNSS and interface them with laser scanners using ground control points. And that's how you can take these points and interface them with the UAVs. And, so really any of these instruments become interoperable with one another. And, Andy, I think that's one of the things that you just do, maybe, quite amazingly, is that you bring so many instruments to the table with what you do in your operation. So, maybe you want to just touch on that for a moment, is how these different instruments cross over.
So with the crossover, each one kind of brings a little bit different perspective or ability to use in a reconstruction or a crime scene map. Obviously, the 3D aspect of a laser scanner that has you get millions of points. You have a high resolution that allows you to work and measure with stuff in a 3D environment is great. The other thing it allows you to do is you can, with the new laser scanners, you can create an ortho image from the scan. So literally you can get the equivalent of an ortho image from a drone from a scan. It's not going to look the same as a photograph, but it allows you to get measurements from that in a 2D environment. Because let's face it, all of us that are sitting here, 3D environment's great, but what do you use most of the time is a 2D map. So to be able to use all this technology together gives you the benefit of having all that data. And some, obviously, if we're looking at the amount of data in a scan versus the amount of data with a GNSS is two different animals. But you may only need the GNSS type of data. So the nice thing that I see is, depending on what you're trying to do, depending on, how advanced you want to get, there's the opportunity to blend it. Some people may never go there. But the point is if you want to go there someday, you're not going to be prevented by going there, because all of this works together. And the workflows, I learned this thing about ground control and all of this when I started with drones. And I have a friend that's a surveyor, and he's like, you're acting like this is new. It's not new. We've been using ground control forever in the survey world. So now understanding it, it's just, think of them like anchors. They're common points that pull everything together. And that's how, they're shot with GNSS. That's how it's done.
Well, and somebody did ask about what drones you're using to do GNSS drone mapping, and really it's of no consequence. Any of the drones that are capturing aerial images, we have our iBot that would do it, and any of the, Andy, I know you work with some different units. Any of the UAVs can capture that aerial imagery and interface with GNSS. And Andy, you've got a great ground control point that you actually have available. That it's a 2x2 orange and black. With the orange, you don't get as much bleed as you do with black and white targets from the air, and so you get a nice crisp line. And so, as long as those oh yeah, I see the orange peeking out over your shoulder there. Look at that. But no, and so those ground control targets, honestly, Andy sent me a set of them, and they have been amazing for me in the work that I've been doing bringing together the GNSS, the GS18, and the laser scanning. And we've actually brought some data sets, MS60, which is a total station that captures point clouds also. It's a scanning total station, and GS18I, and using the ground control points. So bringing all the instruments together. I will say this, I'm really excited for the end of January because I've kind of been corked up with wanting to just unleash a torrent about the GS18I, but we wanted to make this something that builds in a slow burn where we talk about, Andy did a presentation over the summer combining GNSS with UAV. That's available on-demand download. We've got this one talking about GNSS in general, and I'm really looking forward to what we put together for the end of January, because there's a lot more I'd like to show and talk about with GNSS in regard to the GS18I and your ability to measure next to metal, to buildings, and just with, all the things that typically provide interference for one, and then the ability to measure in images, the ability to measure with tilt, all of these things that make it just a stunner. So that's kind of my teaser for what we do in January. I don't want to say much more about it. And my answers to questions are typically very short. Christy's like, this guy.
Yeah, okay.
No. Hey, so
You're
there you have it.
edgewise, Ryan.
Yeah, no, I was just going to say in closing with from my end of this, this type of technology, we wanted today is just to show the advancements and how this may be, the technology may be good for you. I would just say there's different manufacturers and different people out there. All I would say is when you're doing your homework and doing your research, make sure you ask the right questions. And also, if someone's going to tell you it's going to do something, I would ask them to show it to you, because that's the proof that it's going to do what you want to do. And make sure you're specific about telling whoever you're working with what kind of software you have that you want to use with this, what kind of other hardware, like someone asked, that you want to use with this. And make sure you ask the questions and get those answers up front, because once you don't want to be in a position where you buy the stuff and now you're telling your bosses or whoever that this really didn't work out the way I thought it would. So whoever you work with, I don't care what manufacturer it is or salespeople, whatever it is, just make sure that you understand what you're buying and ask the right questions.
Excellent advice.
And I'll say this, and Andy, you and I talked about this, offline, but we advocate for total stations, for UAV, for GNSS, for laser scanners. We're proponents of all of it. We're not here to say that it's GNS or bust at this point, because there's a right tool for the right job. And really, we're just talking about one of those great tools in the tool set.
Yes,
absolutely.
That's perfect.
Absolutely. Well, these two guys, if you have any questions, those of you who are on the line, these two guys can definitely answer anything that you might have. Their contact information is on the screen. This does bring us to the end of our webinar today. I hope that this has been valuable for those of you in the audience. We would like to hear your feedback, so please take a moment to complete the brief survey that should pop up on your screen. If you'd like to learn more about GNSS or other solutions for scene documentation and mapping, please do, again, contact one of our presenters directly. Andy, of course, is very knowledgeable, and Ryan as well. Or visit one of the websites that are up there, forensicmappingsolutions.com or psg.leica-geosystems.us. We will be sending everyone a follow-up email within the next day or two that has links to additional content as well as contact information. And just let us know if we can be of any further help to you on your journey. Thank you very much.
Thank you, everybody.
Thanks all.